3, 2, 1. We are live. Hello, Mike. Hello, everyone.
Hey, Caio. Hey, everyone.
Thank you for joining us. Can you hear us? Can you see us?
How is everyone?
How are you doing, my friends?
Okay.
Everything good? Awesome. All right, don't forget to subscribe to the channel so you don't miss out on new episodes. Quick introduction while we wait for everyone to join us live. In this free series, we are covering the basics of how to build iOS apps with Swift, test-driven development, and a clean and modular architecture. So in this season, season 3, we set two main goals. First, migrate to SwiftUI, which we finished in the last episode. And second, create a rich model layer, which we will start today in this episode. So today you will learn about primitive obsession, which is an anti-pattern, and how to use the Fluent Builder Pattern and the Swift type system to make illegal states unrepresentable in your codebases. And these free live sessions are only possible because of the students of the Essential Developer Academy. So thank you very much for your support throughout the years.
Thank you.
And if you want to take your dev skills to the next level and support our work too, visit academy.essentialdeveloper.com. But not now. Let's focus on the lecture now. So this is how this session is going to work. We'll go fast. And we'll have a quick Q&A session at the end. Make sense?
That's it.
Let me check the chat. Everything good?
All good. And lots
Awesome.
of excitement.
Okay, Tiago is saying that router,
Yes.
the British pronunciation is router. Yes. American accept router and router.
Thank you. It's been an issue for years now, the pronunciation of this word. We've seen numerous comments supporting both sides. Thank you, Tiago, for that.
I use both pronunciations depending of my mood on the day.
Yep, sounds about right.
All right, let's start. Let's get the diagram. Stop here, last episode. So in the previous episode, we showed many architectural and design principles in practice. Those principles helped us create a modular and flexible architecture. We also showed how those principles apply to both object-oriented and functional paradigms, and for both UIKit and SwiftUI apps too. Design principles are agnostic of languages and frameworks and paradigms. And in fact, UIKit and SwiftUI are just UI frameworks, right? So they should live at the boundary here, the infrastructure. So ideally, non-UI modules should be decoupled from those frameworks, right? For example, the presentation is not coupled with SwiftUI or UIKit. It can be reused with both frameworks. The engine as well is agnostic of it. The scoring mechanism is also agnostic of the UI framework, and so on. So that's how you develop a flexible and sustainable code base that scales. Sense?
Yep.
Separate frameworks, make them replaceable. And today we'll cover more design principles that will help you develop Swift code that is easy to understand, develop, use, maintain, and test. Let's have a look at our code base. Boom, here it is. So we created a pretty flexible quiz app from basic primitive data types using arrays, dictionaries, tuples, strings, and so on.
Mhm.
For example here, the option is just a string. Each option is a string. And a collection of options for a question, like the options for the question 1, is an array of options. Also, it's an array of strings. And a collection of questions is an array of questions. Make sense?
Mhm.
So this is pretty flexible. In fact, it's too flexible.
Exactly.
Too flexible because it allows us to represent illegal states. For example, we can create an empty array of questions. That's an illegal state for the quiz. How can you have a quiz with no questions?
Mhm.
Makes no sense. Makes sense?
Yeah, exactly.
There'll be clearly a mistake. And a well-defined model layer should prevent us from representing illegal states. For example, we can create the options dictionary here for question 1. We can pass to just an empty array of options. We can run the app. It's gonna load with no options. How can you play the game with no options?
There you go.
So, representing domain concepts with primitives works, but it's considered an anti-pattern called primitive obsession. So, primitive obsession is using primitive data types to represent domain ideas. Make sense?
Okay.
And there are usually two kinds of primitives: scalars and collections. So scalars are integers, floats, doubles, and so on. And collections are arrays, sets, dictionaries, etc. So there's nothing wrong with scalars and collections. But representing domain ideas with primitive data types leads to code that is hard to understand, use, maintain, and test. And they also lead, as we showed, to code that can get into illegal states.
Exactly.
So one example, classic example is for if you have a credit card number, it has precisely 16 digits. But if you represent it with an integer or a string, there are trillions of illegal states it can be in.
Yes.
Like you can have an empty string representing the credit card number, for example, or ABC. Or if it's an integer, you could have 1, 2, 3, or 0, or minus 200. That's not a credit card number, is it?
It's not.
And so on. What is wrong here? Undo. Boom. Okay. So, primitives usually expose more information than needed, or sometimes even less. As we showed, we can create here a quiz with no questions, for example, with an empty array.
Mhm.
So an array is not a great model for our quiz because it allows states it shouldn't be in. Make sense?
Yes.
We also use the dictionary here for the options. So each question has an array of options. And you can also get into wrong states. So it works, but it can be hard to use correctly. For example, let's try to add a new question to this quiz. Question 3. What is the capital of Brazil? Now we need to create the options for this question. São Paulo? Is it São Paulo? Is it Rio? What is it? Is it Buenos Aires? That's a classic joke. Is it Brasilia? Do you know?
I do.
Check the chat. Who knows?
Let's see. Oh, Rodrigo.
Ah, of course, you're Brazilian.
And Eric. Right there.
All right, so we create the options And then we need to remember to add the options, right? The question key and the options, which is options 3. Options 3. Make sense?
Mm-hmm.
And we need to remember also to add the correct answer for that question. So question 3, what is the correct answer? São Paulo, Rio, or Brasilia?
It's Brasilia, option 9.
There you go. And now, with everything set correctly, we can run the app. And we're going to have an extra question. Whoops. See, I forgot to add it here.
Yep.
There you go. That's how easy it is to make a mistake. Run again. There it is. Boom. Okay. Does it make sense?
Yes. I mean, what a better demonstration, exactly like that. Create a new question, you forget to add it there. You wonder afterwards, where did it go?
Or you may forget to add the options. You may forget to add the correct answer here as well.
Yeah, exactly.
So it works, right? Primitives, they work. And we can even run the app. So here we are running with Swift UI. We can run with the UI kit implementation just by switching the main entry point of the application.
Mm-hmm.
Instead of the Swift UI entry point with main, we can use the app delegate entry point. And boom, it works with UI kit as well. Here's the new question. Make sense? So the quiz app is pretty dynamic. We can change the quiz game by providing different quiz data. But the quiz data is quite cumbersome to manage, and it can lead to mistakes. Also, we have the type single answer question and multiple answer question. So the single answer question should have only a single answer, but nothing stops us by mistake adding 2 options as the correct answer. And you can never get it right because you can only select one.
Exactly.
Let's see. Here, I can only select one option. I can only select one, but the correct answer requires 2. So you can never win this game. It's just wrong. It's the legal state again. So that's it. That's the problem you normally end up with primitives. Moreover, this quiz data is scattered into separate constants, right? We have the questions, the options, and the correct answers. You need to pass these primitives to clients as well. For example, we have the UI kit view controller factory. It needs to be created with the dictionary of options and the correct answers, which is the array of tuples. Again, primitives and primitives. The same thing in the Swift UI navigation adapter. Again, the same primitives all over the code base. So clients need to know how to use those primitives. It works. Many code bases are implemented like this with primitives. You can probably solve any problem with those primitives alone. But it makes your code hard to understand, use, maintain, and test. It also enables illegal states. So this is a small code base so far, and we already start to suffer from this primitive obsession. So they work great in the beginning, but as the app grows, they will make everything more complex. They look simple, but they are not. So don't let their simplicity fool you. That you should create richer types to represent domain concepts. And those richer types behind the scenes may use primitives, of course, but they hide their complexity. Make sense?
Yes.
And they protect the invariants. Like a quiz should never be empty. And so on. So today we're going to start exploring solutions to this challenge, how to represent domain ideas with better types. This is a lot to cover. So we'll start today and carry on in the next episodes. So don't forget to subscribe now to this channel so you don't miss out. In this episode, we'll deal with the creation problem. Like, it's hard to create this data correctly. So this is what we're going to deal with today. Make sense?
Looking forward to it.
So how we can create this data, protecting the invariants, making illegal states unrepresentable as much as possible. So let's spike some ideas first. So one of the problems is that we need to pass these primitives around in the code base. So we could unify those primitives into one struct, right? We could create like a basic quiz, like we have the basic score. We can create a basic quiz. And we can combine here the options, the correct answers, and the questions. So at least now we can pass the basic quiz around rather than just pass the primitives directly.
Okay.
So this is just the first step. And we're giving it a name like basic quiz because we can have different kinds of quizzes. This is the basic quiz, you know, strings, single answer question, multiple answer question, and so on. Maybe you have a quiz with more complex logic, like you may have images or audio, and so on. Then you can define a different domain, a specific domain for your problem. Make sense? So for the domain of this simple basic quiz, we're going to create some domain types to protect invariants for that type of quiz game. Different domains can define their own domain models to define the rules of the quiz they represent. Make sense? We're not trying to make a solution that solves everything, because the solution that solves everything usually doesn't solve anything.
Yes, exactly.
All right. But still, creating this basic quiz here still has the same bunch of steps, right? We need to create them in a correct state, where it has at least one question, and every question has options and correct answer that makes sense for the type of question. So the creation of this type is complex, but it doesn't mean this type needs to be complex. The basic quiz doesn't need to be complex. That's a good case for the builder pattern. Builder pattern separates the construction of a complex object from its representation, so that the same construction process can create different representations. So the idea is to separate the construction of the basic quiz type from its representation, because the construction of it is complex, but its representation doesn't need to be. Make sense?
Fantastic. Yes.
All right. So we could create a new struct called a basic quiz builder, which is a builder specific for the basic quiz domain. We don't want to make it reusable. We don't need it right now. And the basic quiz only responsibility is to protect invariants, enforce those invariants when creating a basic quiz. So you will only be able to create a basic quiz through the builder, which will encapsulate all the complexity of the construction of a quiz in a single place and protect all the invariants. So you can only create a basic quiz with the builder, and the builder will enforce that the quiz was created with the correct state. That's the idea. So we're going to have a function here like build that will return a basic quiz. Or maybe nil if the invariants cannot be enforced. Make sense?
Yes.
So the builder job is to collect all the data the basic quiz needs. And at the end, build a quiz data with this data. The basic quiz with this data.
Mm-hmm.
So this is very similar to the URL components struct. Probably used it. For example, let's import here foundation essential URL function that is supposed to create a URL. So you can use the URL components, which is a type of builder, and you can set the properties one by one, like scheme, HTTPS, the host, essential developer.com, and so on. Right? Creating a URL is quite complex. It has a bunch of rules. There are standards it needs to comply to. You can set a path, like, I don't know, articles. And at the end, you can call URL that will create the URL with the data you set in the component. The URL component is also a struct. Look, it parses and constructs URLs according to the RFC 3986 standard. Make sense?
That's it, yes.
And when you create the URL, if those requirements are not met, new is returned. But if all the requirements are met, you get a URL, well-formed URL that you can use. So I may return new if the standards are not met. Make sense?
Yes.
So we're going to do something very similar to this to protect invariants of the basic quiz. That's the idea. We're going to add one question at a time, protecting the invariants. And at the end, we're going to call build, which should return a basic quiz or new if the invariants cannot be enforced. Make sense?
That's it.
So enough with spiking. Let's undo those changes and let's test drive the implementation. Discard. Boom. Clean state. Run the tests. Passing. Let's carry on. Okay, let's create a test file. But where? Where should we do it? We don't have a domain layer yet. But we have this scoring layer where we have the basic score, which is kind of a domain layer because the scoring mechanism is based on some rules, right? So for now, let's use the scoring folder. We can later extract it to another module, to another framework or package, and also give it a better name. For now, let's do it here. Let's set a test case. So we are testing the basic quiz with builder, basic quiz builder test. All right, initial failing test just to make sure everything is wired correctly. Boom, it is. All right. So what is the simplest test? Let's start from the simplest test we can write. What is it?
The empty case.
Okay, no questions, right? Empty. Empty. So the system under test, the SUT, will be the basic quiz builder. Make sense?
Yep.
Let's create it here. Struct basic quiz builder. Okay. So it starts empty, right? We didn't give it anything. So that's already the empty state. So we need to design what failure means here, right? Because what should happen? If we try to build a basic quiz with an empty builder, it should fail, right? So what is a failure means in this case? It could be nil, right?
It's probably the simplest thing.
Always start with the simplest thing. So if we call build with an empty quiz, we didn't set any data to it, it should return nil when you call build. Make sense? Just like URL components does. So build should return quiz, basic quiz. Basic quiz, optional. So let's just return a basic quiz because I want to see a failing test first. If we return nil, we're going to see the passing test. Make sense?
Okay.
I want to make sure that this test can fail. Boom. Failing.
Fantastic.
So what if we return nil now? It should pass. All right, passing. Let's commit. Fail to build with empty data. Simple step. Commit often, so you can always revert to a passing state. Don't rely on command set. Don't rely on undo. That's my advice. Yes. All right, so nil works for the failure case. But at some point, we're going to have to protect a bunch of invariants. How can the client knows what the problem is? Let's say if we return nil, what is the problem? Is the problem, was it empty? Did it have any like duplicate questions? Or it was missing an option? Like you don't know, right? You need to debug to find out.
Yes.
And this is a problem we have with the URL components API. If it fails to create the URL, you don't know if the problem is the scheme, if it's the host, if it's the path, if it's the query parameters. You know, if you forget to set like the / here, it will fail. It will fail to generate the URL. But like, it's very hard to debug where the problem is. It just returns nil. There's no context, no information. So we can define better APIs. Instead of just returning nil, we could maybe throw an error. If we throw an error, then we can throw a specific error, like missing questions or empty. Make sense?
Yeah.
So this would provide a better API so our clients know what's wrong, instead of just returning nil.
Exactly. More empathetic API, I would say. The clients would know what's going on. Yep.
Or, even better, if we can prevent creating a basic quiz builder with empty questions at compile time. Right? If you can prevent it at compile time, we don't need to unwrap the optional or handle errors at runtime. The compiler will enforce the correct state, which is the best way to prevent mistakes. You cannot even compile the code if it's wrong.
That's it, yes.
So we make the illegal state unrepresentable. So as much as possible, let's use the type system to prevent mistakes. So if an empty quiz is illegal, is an illegal state, we shouldn't allow our clients to create a builder in an illegal state. Make sense?
Yes.
So how can we do it? Initializer injection that we showed in the previous episode. It's a dependency injection pattern where we pass the dependencies in the initializer. So in this case, let's say we are testing the single answer question case. We can pass here like Q1. So now we are starting a quiz builder with a question, which means it always starts with at least one question. It's never empty. And we are enforcing it with the initializer. Make sense?
That's it, yeah.
We can create now an initializer for this case, like this. Make sense? So now we don't need to return optional. It can never be in the wrong state. It can never be in a state where there are no questions. Thus, our APIs can reflect that and return always a basic quiz. Make sense?
Fantastic, yes.
Should not return optional anymore. So we can change our assertion as well. What do we need to assert here? If we can represent the illegal state, we don't need to write a test for that state. We are checking with the compiler, the type system will enforce that. Thus, you don't need to write a test. Make sense?
Yes.
You can ever get in that state. So how can you write a test for it? That's the best way, when you can use the compiler to enforce these invariants. That's why good types are important. They can save you time and make your code base safer. So we can go straight to asserting the correct state that we expect here. So if we build, we expect the questions within the basic quiz struct to contain a single answer question holding the Q1 value that we passed. Make sense?
Yes.
So we need to define what questions are in a basic quiz. Again, let's get the type from our current quiz data. It's just an array of question, which is an enum. So we need to import here. It's defined in the
Quiz
engine.
Yeah.
For now. There it is. Just a simple enum to differentiate single answer from multiple answer. Make sense? I think now we can run the tests. Oh. There you go, type system helping us enforce the correct setup. Again, questions. And I want to see a failing test, so let's pass an empty array for now. Boom, failing. Let's also rename this test. It's not the empty case anymore. It's the init with what? Single answer question.
Yes.
There it is. So now, run the test again, and let's make it pass.
Fantastic.
So again, the builder will collect this data, but privately. So we can build the quiz. So it's going to enforce the invariants, collecting the data one by one, question by question. And when you call build, you will build the basic quiz with the questions that are always in the right state. So let's set the questions. Here it's just a single answer with the given single answer question. And here we can pass questions.
That's it.
This is just the first invariant we are enforcing. We should always have at least one question. Boom. Passing. Let's commit. Notice how the primitives here, the array of questions, is private and constant. It can only be changed, it can only be set from the inside here of the builder. Because then we can protect the invariants for this type. Make sense?
Yes, exactly.
Also important to notice how the test helps us validate the design, since the tests are the first client of the API, right? So we can design the API as a client from the client point of view. How the client will use this type. We are free to play around with ideas and validate the result. Because with flexible and reliable tests, we can always refactor the code with confidence. But the tests don't do the design for you. They help you define the APIs, but you are the designer of the APIs, not the tests. So tests don't do magic. The API will be good if you're a good API designer. Make sense? Let's commit. Prevent creating builder without a question. First invariant. Boom. All right. And every question should have at least one option. One or more. Never empty as well. So the options should also be a mandatory argument in the constructor, like options. And we pass an array of options. But arrays can be empty.
Yeah.
Make sense?
Yeah, exactly. So this is not going to do it.
So options array of string in this case. We can pass an empty array, which is an invalid state. We should always have at least one option. So we need to ensure the array is not empty. Again, we could make this initializer like failable by returning nil in this case. So guard not options is empty, else we return nil. Sense?
Yeah.
But again, clients won't know what is wrong. The more invariants it needs to protect, the harder it is for the client to debug the problem. So we could throw an error instead. And here we can throw something like an empty options error. Make sense? But can we use the type system to prevent this mistake?
Okay, so the compiler wouldn't even let us create and pass an empty array there.
Exactly. So how can we represent a no-empty array? Can create a new type. Can call it like non-empty options. Make sense?
Yes.
And we can define here the first option. So there's always at least the first option. And let's say the rest. Something like this.
That's it.
Make sense?
Fantastic. Yes.
So this type can only be created with at least one option, the first element. And now if we define this type here, non-empty options, you need to pass some options, at least one. So here you can say like option 1, rest, I don't know, option 2, 3, so on.
Okay.
Make sense?
Yeah, that's nice.
But the rest can be empty. Doesn't matter.
Exactly. As long as you have the first one.
So this way we can avoid throwing or returning nil in this case. You cannot compile if you don't provide at least one option.
Yeah, and that's the rule for this basic quiz, right? Maybe it's 2, you know.
Maybe it's 2, exactly. Then you can define first, second, and so on, right? It depends on your rules. Here, at least
Awesome.
1. Maybe you have at least 3, 4, I don't know. Also, this non-empty array type here can be generic for any non-empty array. Usually we call the first and rest head and tail. And you can also define here a generic type. So it can be a non-empty array of anything, not just strings. You can also make it conform to sequence. Whoop. Make sense? But we don't need all this flexibility right now. So let's keep it simple.
Yeah.
We'll leave it as an exercise to you. And we can cover it in a future episode if you're interested. But we don't need it right now. All right. So head, tail. Let's give them 2 options. Maybe 3. O1, O2, O3. Make sense?
Okay, yep.
Let's now add an assertion. XCT assert equal. So if we build again, so let's build only once. Let's create a result constant. There you go. Result questions, result options. And result options is a dictionary. Question as the key and array of string as the options. Okay, let's bring it here. So the key is single answer key 1. And the options should be an array with options O1, O2, and O3. Make sense?
That's it.
So the basic quiz builder APIs are preventing the wrong states, but behind the scenes, it will create still the primitives we are using so far. Make sense?
Mm-hmm.
Can we run the tests? Okay, compiler helping us do the right thing again. Options, let's pass empty now. See a failing test first. Failing. Empty. Make sense?
Yeah.
Let's make it pass.
Yeah.
Private constant again. Whoops. Options. And here we can set options equals single answer. Let me copy this. Where the options is options head plus options tail.
Mm-hmm.
Make sense? We are combining the options. So the API prevent mistakes. And within the method, we need to combine them.
Okay. What is wrong? You're confused.
The name options and options. Let's use self.
Oh, okay.
Self dot.
Yeah.
There you go. Let's build. Still failing, because now we need to pass the options here. Passing. Let's now extract. The question. There it is. I think we can simplify here. Question dot. That's enough.
Yeah.
Same here. We can reuse the question.
Exactly.
Boom.
Yes.
Passing. Let's commit. So enforce that every question has at least one option. Make sense?
Yeah, and I really like this process, starting from returning nil if the input is not valid, then moving to throwing an error specifying what is not valid, and then making it impossible to represent that whether it's type. This is very nice. Yes.
But normally people ask us, can I just go straight to the one with the type system? Of course.
Mm.
If you already know this API, if you already know how to do it, of course you can skip the other steps. But when you are discovering the APIs you need from the client point of view with the tests, maybe you start with the simplest thing you can think of and you advance it, try to use the compiler, the type system as much as you can. And refactor, refactor, refactor.
Exactly.
Make sense?
Mm-hmm.
Right, there's one thing this API doesn't prevent. Creating options with duplicate values. Let's create a test for it. What should happen? Duplicate options. For example, O1, O1, twice. Does it make sense to have the same option twice? Not in this quiz. Maybe it does in your use case, not here. So here we could use sets. But sets will make the values unique, right? We enforce uniqueness of the values we set, but we lose order. We lose the order of the elements. But order is important for us. We want to present the options in a specific order, not randomly. Mm. So we could use an NS ordered set from foundation. But look at that. We lose the type information. Everything is going to be an array of, it's going to be any.
Any, yes.
So we lose the type information if ordered set. That's an Objective-C class. So here, unfortunately, we won't be able to use the type system to prevent this mistake, unless you create your own ordered set implementation or use someone else's. There are some libraries on GitHub But we can use this opportunity to show how to preserve invariants when you can't do it with the type system. So here we can return nil or throw an error. And I prefer throwing an error when I can provide more context to the client. So they know what they need to do to fix it. Make sense?
Yes.
So let's change our tests to throws now. Throws. And we need to call the initializer with the try keyword, because it may fail. So here in the test, if it fails, it will throw. It will not crash. Exit test will capture the error and generate a failing assertion, a failing test. So it's perfect. Make sense?
That's it. Yep.
Now, let's change here the test. When we have a duplicate option, we want to throw. So here we want to throw. But if it throws, it's going to fail. Actually, we want it to fail if it doesn't throw.
Right.
Make sense?
Exactly.
So we can use the assert throws error. If it doesn't throw, it will fail. Make sense? And we can perform the operation within the assert throws error helper, like this. Make sense?
Yes.
So we don't need any of this. So if it throws, you can check the API here. We have an error handler closure as the last parameter to this assertion. So here we can capture the error. And if you want to check which error was thrown, you can do it here. If it's important for you to check the error type, you can do it here. So in our case, let's make sure that we are throwing the right error type. So we could have an error type, like a basic quiz builder, like an adding error. So when you are adding data to the quiz. And we can compare it to the type we want. So if we have the basic quiz builder adding error of type duplicate options.
Okay.
Something like this. Make sense?
Yeah. Yeah.
We could even pass the data to help the clients diagnose the problem within the error. So here it should be 01, 01, 03. Like this. So this is the data provided. There's something wrong. Please fix it. Make sense?
That's it.
So this would be a nice API. If there's an error, they know precisely where the error is. All right. Let's define our error type. How did you call it? Adding error. Enum adding error. Case duplicate options. Array of string, right?
Yeah.
So we passed the duplicate options. Let's run the test.
There is a parenthesis missing on 56 before the trailing closure. Yeah, closing the assert rows.
Like this?
I think so. Okay, let's see. So 1, 2, 3.
What is wrong? What is wrong?
Is there another? Yeah, at the bottom we need a brace, I think.
All right. That's it.
That's it. Okay.
So we need to make our error, first of all, equitable and conform to error. So we can throw it. Boom. Look at that.
There you go.
Did not throw an error. It failed because it did not throw. And it should have, because this is an invalid or illegal state. Make sense?
So
we can add a guard here. Guard set of options, which it gets all the options here. Let's create a helper.
Okay, yeah.
Let all options equals this. Make sense? We can use here all options as well. So if we convert all options to a set, and we get a count, and we compare it to the all options count, it should be the same. If it's not the same, it means that we have some duplicates. Make sense? Because the set will remove duplicates, so it will change the count. That's just a simple way of checking for unique values in an array. And here we should throw duplicate options and pass all options. Make sense?
Yes.
Turn the test. Boom, passing.
Exactly.
Not the refactoring.
Yes, notice that.
Sorry?
Notice that we're not passing the set version of all options. We are including the duplicate in our feedback.
Yes, you want to present all the data so the client knows what is wrong. They can see that, oh yeah, duplicate options, oh, 01, 01. There we go. I can fix it. Make sense?
Yep.
You can also add a helper here. Let's do some refactoring. Then no empty options, we can have a helper like computer var all. That does that work for us. Here's just head plus tail. Make sense? Run the test again. Passing. With tests, it's safe to refactor. Actually, you can only refactor with tests, otherwise something else.
Shooting in the dark.
Prevent duplicate options for questions. Make sense so far?
Should make sense, I think. Everything is very clear. But yeah.
Okay, so now we need to define the correct answer. The correct answer for the single answer question type, which should be only a single answer, right? It's a single answer question. It should have only a single answer. So we can use, again, the type system to enforce that. For example, if we provide an answer, in this case, it's 01. So we have a bunch of options, 01, 02, 03, and the answer is 01 only. It's not an array of options, right? It's a single one. The type system we enforce, you can only provide one answer for the single answer question. Make sense?
Yes.
A multiple answer question can have an array or a no empty options. We enforce there's at least one answer. Make sense?
Yes. Awesome.
But here, let's use the type system and enforce. You should always have an answer and a single one. It's not optional. It's not an array. It's a mandatory single answer. Make sense?
Yes.
Now, what is the type for the correct answers? Array of tuple. Let's bring it. Array of tuples. So here, correct answers should be an array of tuples. In this case, question 1, answer is a single 01 answer. Make sense? Am I missing something here? Oh, parentheses.
Yep.
That's it.
And one more parenthesis for the assertEqual.
We also need to provide an answer here.
Ah, yeah.
01. Anything, doesn't matter.
Okay. Yeah, and this is that tuples are not equatable.
Yes. Tuples are not equatable yet in Swift 5.3, unfortunately. Hopefully they will be at some point. So we dealt with this problem in a previous episode. We created the assert equals, a custom assertion. Yes, there it is. or custom assertion that uses the equal function, because tuples are not equatable, but they provide an equal function. So we can create our helper here, following this idea. Helpers. All right, can even make this private. And the type is array of question and options array of string, like this.
Okay.
You can also refactor it, private, refactor it to make it generic over any equatable. Let's keep it simple for now. Now we can use assertEqual, our custom assertion. All right, now we can provide here correct answers, just empty. Let's see a failing test. Boom, there it is. Failing test.
Fantastic.
Now, private correct answers and self correct answers is tuple question and answer, single answer. Now we can pass it here, run the test, passing.
Okay.
Awesome. As you can see here, our builder is starting to collect all the data it needs to build the basic quiz data, protecting the invariants. So let's commit. Enforce that every single answer question has a single and only answer. All right. There is another invariant we need to protect here. What if the answer is not contained in the options? How can you win? Let's create a new case here. So missing answer in options. Make sense?
Yeah.
So 01, 02, 03, but the answer is 04. So you cannot select 04 because it's not an option.
Yeah, it doesn't exist.
So here you should throw missing answer in options, where we provide what was the provided answer. In this case, it's a single 04. And the options 01, 02, 03. Makes sense?
Yes. Yes.
Let's add this new error case. Answer is an array of options, and options is also an array of options.
Okay.
Okay, failing test. It allows this wrong illegal state. Let's enforce it now. So guard all options contains answer, else we throw adding error, missing answer, single answer in this case, and these are all the options we have. So the client can see what is wrong. Run the test. Passing. Commit. Prevent missing answer in options. Make sense? Okay, so we can create a quiz builder with at least one question and we enforce the invariants. But we should also be able to add more questions to it, step by step, one question at a time. And there are two common ways we can do it with the builder pattern. One is to create mutating functions that will mutate the builder, like the URL components does. So every time we add a new question, we get a new builder through the mutation. Make sense?
Yeah.
So let's add a test to design this API. All right. So here we create our quiz with at least one question. Then we should be able to mutate it. So add single answer question. So how can we add a single answer question here? We can create an API like add and pass the same data. Like this.
Okay. So Q2.
Question 2, option, I don't know, 3, 4, 5, answer 3. Make sense? This will be the API. But we cannot mutate a let. This is a struct. We need to make it a var. So we are mutating the builder. So it needs to be a var. Make sense? Because the builder is a struct.
Yes,
so every time we mutate it, we are reassigning a new struct to this variable. Make sense?
That's it.
Let's create now this API. I'm just going to copy this code here for now. Then we can deal with the application. First, make it work. Then make it right.
Make it work.
Then make it fast. That's the order. So we have a mutating function, add, like this, with the same logic here. Make sense?
Okay. Okay.
So if I'm mutating it, those primitives here that we are accumulating should also be variables. But again, they are private. We can only mutate them through these APIs that preserve the invariants. Make sense?
Okay.
For now, let's do nothing, just to see a failing test. So the API is ready. We can mutate SUT, but if I set this to let again, boom, the compiler helps us do the right thing. Now the assertions, we should have two questions. Q1 and Q2. Make sense?
Yep.
And we should have options for both.
Questions, yes.
Q1, Q2. Options for Q2 is 3, well, and 4 and 5. And the answers? Both Q1 and Q2, but the answer for Q2 is 03. Make sense?
That's it.
Am I missing something here?
Yeah, the 130, 131, I think we need to have more bracket. Yeah, yeah, that's it.
That's it. Let's run the test. It should fail. There you go.
Fantastic.
We can also add those tests here to protect invariants. So if we start our SUT here correctly, and then we try to mutate it, but we are adding a question with a duplicate option, you should throw. Make sense?
Yes.
You should not mutate it, because it should protect invariants.
Awesome.
So add single answer question with duplicate option, throw. And add single answer question, missing answering options, should also throw.
let's update on 153 also the options there, because now it's 335.
True. 335. And here, missing answer in options. We have 06. 06, 345. That's it. No mistakes. We'll see. Let's run the test.
See.
All right, it's not throwing, failing. Now, let's uncomment the code here. Let's make it pass. So the questions we need to add, right? We shouldn't replace it, but we should add this new question to the questions. We should also add the new correct answer for this question into the correct answers array of tuples. But we cannot add a new element to a dictionary with this syntax. But we can create here quickly. New options is the current options, but a variable, mutable. New options for this question is all the new options.
Okay.
Makes sense? So we are mutating self.
Okay, and 64 needs to go up. That's easy.
It's one of the tests. It's passing. All right, so we can add questions. Make sense?
Awesome. Yeah. I mean, yeah, it's exactly the same thing that we're doing.
Add single answer question enforcing invariants.
Beautiful.
So we also need to prevent adding the same question twice. Again, this is a specific rule in this basic quiz game. We shouldn't have the same question twice. Doesn't make sense. Maybe you have a quiz that could have duplicate questions. Why not? If that's your case, you create a different domain layer to preserve the invariants for your use case. Different types, different models. Make sense?
Yep.
All right. Let's add a new test. If we're adding single answer question, duplicate question. Whoops.
Question.
To throw.
Yep.
Right? So if you're adding Q1 again, even if they have different options, which also doesn't make sense,
yeah,
should throw. Right? Because it's duplicate. So
maybe let's set the correct answer to be one of the options as well, so there is no confusion.
No conflict. All right. So duplicate question here should be dot single answer Q1. That's the one that is duplicate.
Awesome.
Make sense?
Yes.
So let's set this new error case, adding error. As you can see, this is for adding. If you have different kind of validations, you should probably go into a separate enum. And the type of the question is the question enum with the string as the generic constraint. All right, run the test, should fail. We're not checking this invariant yet. Failing. So we need to add this check now here. When we are adding, we don't need to add it in the initializer because you initialize, you have only one question when you create this builder. So you cannot ever have two questions that are the same.
Yeah.
You have only one question. But when you are adding, they might be duplicate. So here, we can move this up. You can check guard questions contains question or not should not contain. Does should throw adding error, duplicate question. Let's run. Boom, passing.
Awesome.
Commit, prevent duplicate questions. Okay, so we have a bunch of duplication here. Let's refactor a little bit. We can create a helper to check for adding error. So we could probably follow the same syntax here for the assert throws. We don't need a message. We don't need an error handler. Let's copy here. Let's call it assert. And we can pass here what it should throw. So assert throws expected error.
Yeah.
And the type is adding error. Like this. Then we can compare with the expected error. Make sense?
Yeah, and the expression needs to be substituted.
And here it's try expression. Make sense? Let's also pass the file and line to the assertEqual, so we can show the error precisely where it happened.
Awesome.
That's it.
We need the parent. Oh no. No, it's a trailing.
That's it.
Yep.
Assert that this expression throws this expected error. Fantastic. Now we can call assert, pass the expression, and say throws, in this case, duplicate.
Awesome. Yeah. Because it knows the type of the enum.
Like this.
Huh. Yeah.
Awesome. Assert. And in this case, throws. What should it throw here? That's it. Look at that. Run the test. Passing. Next. Assert. Throws. Duplicate options. Awesome. Everywhere.
Everywhere.
Should probably have done this sooner. Don't wait to refactor. That's what happens. Not that bad.
It's fine.
Throws. Boom, that's it. Probably saved, I don't know, 20, 30 lines of code here. Let's commit extract duplication into test helper. All right. So we say there are two solutions to the builder, two common solutions to implement the builder. One is the mutable one. As you can see, you need to get a variable and mutate it every time you are adding more data to it. Another solution is the Fluent Builder Pattern, where we don't mutate it, but every time we add a question, we get a new builder without modifying the original one. Let's add a new test to show it. So instead of a var, we're going to have our city as a let, because we're not going to mutate it. Now we can call the method directly and chain it like this. So instead of mutating, very procedural, we can chain the operations and always get a new builder for every operation. Make sense?
Okay. Yeah, exactly. That's what the ing at the end of add is as well.
Yes.
Denoting that we are returning a new builder.
Yeah, the naming convention is the mutation, right? The mutable solution is a command. Mm-hmm. You are commanding it to mutate itself, for example, like add, do it, you know?
Yeah.
In the immutable one, it returns a new type, right? So we normally use the adding or inserting, which returns something new, a new type by the action of inserting or adding something to it, right? It implies that it returns something, when a command implies that it's going to perform some side effects. Make sense? That's the naming convention. Can we improve this indentation here? What do you think? Like this? Better?
I think so, yes.
Okay, so adding. But the assertion should be exactly the same. Regardless if you're mutating or if you're getting a new value, the result should be the same. Make sense?
Yes, absolutely.
Just a different API. So we are not mutating this struct anymore. The compiler will enforce that. Again, the type system can help us do it. Let's also add the other invariant tests. No, just these ones. All right, so let, we just convert it to let. The compiler won't let us call add, so we can call adding. So get compile time safety here.
Beautiful.
So here, adding, let, adding. So we're just changing the API. The result should be exactly the same. In fact, we are maintaining the old API at the same time, so we can compare them later on. Make sense? All the tests?
That's it.
Calling,
yep,
adding.
I think so.
And if we do anything wrong here, forget, the compiler is going to tell us it's wrong. You cannot mutate a let. Let is a constant. Boom. So we have this API, add. Let's now duplicate it again. More duplication. We're going to deal with duplication soon. Don't worry. So the adding API, again, should not be mutating. Okay, we're not going to mutate it. We return a new builder every time. So basic quiz builder is the return type. Make sense? Instead of mutating self, we're going to return a new builder. So single answer questions is questions plus the new question. Make sense? The options is the new options. And the answer is the correct answers plus the new one. And then we can chain it. That's all it's called Fluent Builder implementation. Because you can chain them like this. And you can call adding, 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 and so on, like many times. You can fluently chain the operations. Make sense? So we need to be able to create a quiz builder with the primitives, right? So here we have the questions, options, correct answers. So here we should have questions, options, correct answers. But we don't have an initializer to start with those primitives. We can create one. But what is the problem now? clients can create a quiz builder now with wrong setups without enforcing the invariants.
Yes.
How can we protect it? Again, access control. Make it private. Make it private.
Exactly.
Clients can only use the APIs that enforce the invariants. Everything else, they are internal helpers. Make sense?
Mm-hmm.
Protect the invariants in your models. With access control. It's private. No one can call it. Only internally. And we have tests to enforce everything is correct. Make sense? Let's run the tests. Passing. Fantastic. Let's commit.
Commit.
Implement Fluent Builder API without mutation. Now let's deal with the application. All those methods are doing almost the same thing. Or the same thing.
Yeah. Odd.
So we can now delegate messages here to one of the methods in the initializer. So we can set the initial state, which is empty. And then we can call try add, which will mutate itself. And we pass the data. Like this. So run the tests. Should still pass, because the add method also protects the invariants. Make sense?
Beautiful. Yes.
All right. Another thing we can do, so we don't need to set this initial state, is to set it here as default values for the variables. Again, it's private. No one needs to know about it. Run the test again. Passing. We still have the application in these two methods. So one can delegate to the other. Make sense? Either the adding calls add or add calls adding.
Yeah.
Let's make add call adding. How can we do it? In the mutating function, we can reassign self. So we can say self equals adding, adding single answer question options answer. So this will return a new struct. Of course, we need to try. This will return a new struct, a new builder, and we're going to assign this new builder instance to self. So we mutate self. Because every time you mutate a struct, you reassign self. That's what happens behind the scenes. Let's run. Boom, passing. No more duplication. Okay. Just delegating methods. Make sense?
Yes, awesome.
So those are the two main ways I recommend for implementing the builder pattern in Swift using structs. In fact, you can mix these both approaches. You can provide both APIs. Why not? So your clients can decide which one to use depending on their use case. If they want to mutate, they can mutate. If they want to chain the Fluent Builder APIs, they can chain it as well. They can even mix both as needed. They all enforce the invariants. Make sense?
That's it.
Because this is a struct and the compiler will enforce also the discipline on mutation, right? Especially around mutation. Structs are usually safer choice for builders. So I recommend you create builders usually as structs. Make sense? The structs are passed as copy as well. So they are safe to pass around. You don't need to fear another component mutating it if you don't want that to happen. So here we're going to keep both implementations. Okay?
Awesome.
Run the test again and let's commit. Remove the application. So that's it for adding single answer question. Now we have multiple answer question, which is very similar. So I won't make you watch me type it.
Okay.
Let me just show you the solution and you can try and implement it as an exercise. It'll be fun. Try it. Do it. Let me get it here. All right. So this is the builder with both single answer question and multiple answer question. Look how the answer for the multiple answer question is a non-empty options. It needs to have at least one option for the answer. Make sense?
Yeah, exactly.
And it also protects all the invariants. You also have the mutable and the Fluent API. And they all delegate to this adding function. So we have no duplication. Sense?
Fantastic. Yes.
We also check for duplicate answers, which is possible
yeah,
in the multiple answer question, but it's an illegal state, so we need to throw duplicate answers. Make sense?
Yep.
Try implementing this. It's going to be a good exercise. I promise you have fun. If you like programming.
Yep.
All right, let's move these types now to production and let's see it in practice, right? Let's use it. Demo quiz now. Let's paste it here. And let's create this demo quiz data here with these new APIs. Let's see how easy it is. So demo quiz is, first of all, we need to try. And since we are hard coding here, I'm going to use try-bank because I know the values are not wrong. And if it's wrong, it's a programmer mistake because those values are hard-coded. Just like when you create a URL and you are passing here a string hard-coded and you know it's a valid URL. You don't need to unwrap it, right?
Yep.
It's hard-coded. So we know it won't fail. Make sense? So basic quiz builder. Where's the autocomplete?
Left the building.
You gave up. Okay. Single answer question. It's lowercase. Come on, Swift. First question. What is Mike's nationality? Now we need to provide options, which has the head, the first one, Canadian, and the tail, which is the rest, American or Greek. Make sense? What else? Answer. What is the answer? Greek. If you don't know, Mike is Greek.
That is true.
Right? And we can build like this. Just one question. Build. Now the next question. Let's use the Fluent API. I prefer the Fluent API. I really like the Fluent API.
Yeah, same for me. I think it's more fun chaining stuff.
Oops. So the second question is a multiple answer question. So multiple answer question. What are Caio's nationalities? So options, Portuguese, American, Brazilian. Answer, can you see? The compiler doesn't let me do the wrong thing here. I need to provide non-empty options for the multiple answer question. So the answer is Brazilian, Portuguese. Make sense? That's how easy it is now to create a quiz. You cannot do it wrong. If it's wrong, it's going to fail. Or it's not even going to compile. Let's remove these primitives. Let's fix the composition root. Instead of accessing those primitives directly, we can use demo quiz options for the Swift UI composition and the UIKit composition. Does it make sense? What are we doing here?
That's it. Yeah, I mean, it should, right? Exactly.
Let's run the app. Boom, still works. Ta-da, there it is. Now let's say we want to add a new question. We just chain. Like this. What is the capital of Brazil? São Paulo. Whoops. Rio. Brasilia. It's Brasilia. Boom, there it is. If you set the wrong answers, boom, you get the error and 0 out of 3 correct. There you go. So much easier now to add new questions to this quiz and enforce the invariance. But there is still a lot to do here. Still a lot to do.
Yeah. And if you provide, let's say, the wrong answer there, let's say you put another city, for example, we would crash at this time, right? With a very specific and descriptive error.
Yes. Let's show. If we set here, I don't know, Buenos Aires, which is not even in Brazil.
Learn coding and geography in this series.
Fatal error. Missing answer in options. Answer, Buenos Aires, options. It's not there. Make sense? So it's a friendly API with your clients.
Awesome. Yes. Okay. Fantastic.
So again, we are using this try bank here because we're hard coding these questions. It will be a programmer mistake and we want to get a crash if it's a programmer mistake so we can fix it before releasing the app, right? We have tests for all of that. Now, if you're getting this data from a backend API, from a service, then you should validate this and not use try bank, right? If it comes from an external source, you should not trust that data, ever. Don't use try bank. Don't force and wrap things that came from external sources.
Of course.
And user input is an external source as well. You cannot trust this dynamic data coming from external sources, right? So if the user enters the questions, let's say you created an app, a quiz builder app, that the user can enter the questions and answers. You can use this quiz builder to validate the invariance. And if there's an error, you're going to capture the error, check the type, and show a nice message to the user. Hey, it's missing the answer in the options, for example. Make sense?
Yes.
So you can use the builder, not just hard coding it, but to validate external sources input. So the basic quiz is still very simple. It doesn't have any of the complexities that it requires to create it. We separated the complexity of creation from the type itself with the builder pattern. Make sense?
Yes. Exactly.
And again, we're not just using builder pattern because it's cool. It's because we have a problem and there is this well-documented design pattern, this solution that works. We just don't use UI patterns because they're cool, because they solve specific problems in a nice way, right? They have the recipe for solving specific problems. So the creation problem here for complex objects, one of them is to use the builder pattern. Make sense?
Exactly. We are decoupling the complexity from the creation because these are complex objects to create. I mean, this is a sample here, right? With the validation rules that we added today, but you may have more validation rules. For example, we still deal with strings, like, you know, what if the string is empty or something else that is problematic in your case? You have to deal with that. You have to check for that. So I think you mentioned it while you were typing it that we have this adding enum, right? Adding error.
Yes.
But you can have a bunch of other types of errors.
Exactly.
Yeah. Right. So yeah, you want to be, robust, and you need to check for these things. And this is how you do it. This is how you concentrate the validation in one place and you don't let it leak throughout your application. So the rest of the layers, they don't know anything about these things. They just get input and they consider it that it's good.
Exactly. Everyone using the basic quiz in any module should know that this data has been validated and it's
Yeah.
correct. It's never in an illegal state. Make sense? Because the idea is that the initializer for the basic quiz should be internal or even private. Clients shouldn't be able to create the basic quiz directly because it could be in a wrong state. Only the quiz builder should be public. So you can move this basic quiz to a new module, as we're going to do in a new episode, and keep the initializer internal or private, and only the builder initializer public, and only the ones that protect the invariants. Make sense?
Yes.
So we use access control to prevent those mistakes as well. Again, the type system, the compiler, enforcing these invariants for us. And again, the test is the first client of this API, so we can also test the access control here as well. So we're going to import the quiz app. We just move the types here out of the test file, so it doesn't have access to it. So we can import the quiz app, but importing a module only gives you access to the public interfaces. Make sense?
Yes.
Unless in the test you make it testable, and then you have access to the internal interfaces as well. But I want my tests here to test as a client that doesn't have access to the internal properties, like a client would, right? I want my test to be the first client of this API. And now the test is going to tell me which APIs should be public. And we only make the publics the ones that protect invariants. So here, the quiz can be public, no problem. The properties can be public as well, but not the initializer. The initializer is by default internal. Make sense? If you don't create one, a public one, it's internal. No one can create this basic quiz. Now, no empty options, no problem here. We can create a public initializer. Make sense? Whoops. Like this. So the test can create no empty options, which is mandatory for this API. Also the builder public, adding error. We also want the clients to have access to the error so they can investigate problems and solve it. This should be private. It doesn't protect invariants. This one does. This initializer also does. The mutating function protecting variants. Adding as well. The adding APIs, the Fluent APIs protecting variants. And of course, we need to be able to build the basic quiz. Everything else is private.
Yeah.
Make sense? Now we should be able to run the test. So the test doesn't have access to the internal types. So the test has the same level of access as a client of this module will. So if I try to create a basic quiz here, initializer inaccessible. Make sense? Just like clients cannot create the basic quiz. They need to use the builder, which is the only public API. And that's how we can use access control to protect the invariants as well. Make sense? So when we create our domain module, that could be a package or a framework, we'll move these types there. And you can only create basic quiz through the builder. And then we have the module level access control protecting the invariants for us as well. Make sense? So that's it for this live session. We covered how to use the type system and the builder pattern to make illegal states unrepresentable when creating complex instances. So as much as possible, we try to use the compiler to prevent mistakes. And we protect other invariants with logic at runtime. You also learn how to use tests to help you design your APIs, as the test is the first client of the API. There's so much more we are going to cover in this series. But this is just the first step to eliminate primitive obsession. You'll learn much more in the next episodes. So, if you enjoyed this session, like the video and subscribe to the channel now so you don't miss out on future episodes. Come on, like. Subscribe. Now, let's have a quick Q&A.
Okay, I have a bunch of comments.
Let's see, questions.
Okay. First of all, is this left online for a bit? I'm actually at work and would love to watch a bit later.
Sorry, what is the question?
Yes. If the video is going to be left online.
Yes.
It will, yes. Yes, and Noureddin replied. Thank you, Noureddin.
When you say no UIKit modules outside of presentation layer, do you apply that to CG point, UI color, UI image types of classes, and so on? If you want your presentation to be decoupled from UIKit, yes. It should not reference any UIKit type, including UI color, UI image, and so on. But if you're happy to couple the presentation with the UI framework, you can import UIKit in your presentation layer as well. It's a choice. Yeah, and I think CG point might be foundation rather. Core graphics. CG, core graphics. Something like that.
Yeah, Valentin asks, do we not need to throw if single question or answer is empty string? It's up to you. It's like you can create all kinds of rules that make sense.
Yeah, still
for your
using
output.
the questions as primitives, as strings, might be a case of primitive obsession as well. And in next episodes, we're going to show how to prevent these kind of mistakes like empty string as well. But this is not part of creating the quiz yet.
Yeah.
We're going to protect invariants of what a question is, what an option is, you know,
exactly,
in a different domain type, not in the builder. The builder just protects invariants of the quiz structure, the data structure. We still need to define what a question is, what an option is, with better types. We're going to do it in the next episodes.
Same for why not making that tuple into a type now? Yeah, falls under the same category.
What else?
Okay, that's interesting. Gordon says, the builder feels very much like a view model that exposes a quiz property. Okay.
A lot of patterns, they are similar to, like, you can say that view model is an adapter as well, because it adapts the domain model to the UI, right? But then we give them different names because they have very specific roles in the UI, right? In the architecture of your code base.
Exactly. Maybe if you see it like this, as Gordon proposes, it's easier to visualize what a view model is and how you should use it, you know, as this adapting layer that has a bunch of rules and just exposes what the UI needs.
Yeah, but I wouldn't say the builder is a view model. I don't see the similarities in this case.
No.
Because here we are building data, right? And a view model will get this data and translate to what the UI needs, right?
Yeah.
Some presentable data. This is not presentable data, or it shouldn't be. It's just the quiz data.
Yes,
you need to translate that data structure to something that you can render on the screen.
Yes.
We'll learn more in future episodes as well. What are the differences between builder and factory? Well, you saw the builder today. See the factory 2 episodes ago, episode 4. We show the factory pattern. But mainly a factory, you just ask for it to create something, right? Where the builder, you do things like usually step by step. You keep adding the data until you're ready to build the thing you need. What else? What is domain layer? where you keep your domain logic.
Mm-hmm. Yes, types as well.
Usually, if you want to learn more, you could read the domain-driven design book. Very good book. Difficult to read, but mandatory in my opinion. It's a place in your code base, the domain layer, where you're gonna have your models. There, usually you want it to be decoupled from every other layer. It's like the core of the application, where you define the rules. And on top of that, you have the presentation layer, navigation, and so on. Builder.
Okay, if you keep committing, it will show a big list of commits when you raise a PR.
What's the problem?
Can we hide that?
Yes, you can merge or squash the commits. But what is the problem with a big list of commits?
No, it's not a big list of commits. It's a big list of commits when you create a PR, which I think that raises another issue, which is don't create long PRs. Just merge often. You don't have this problem anymore. But yeah, of course, also a big list of commits is no issue at all. Something actually that you probably want.
Which platform are you using? Visual Studio? No, Xcode.
Yeah.
That's it?
I think so. Yep.
All right, that's it then. So, if you want to take your dev skills to the next level and support our work, we are running a free online event next week. The event is called iOS Dev Career Week, and it's a full week of lectures and coding sessions to take your iOS dev career to the next level. It starts very soon, on Monday. Visit academy.essentialdeveloper.com and sign up now. academy.essentialdeveloper.com.
Awesome.
See you there next week. Thank you for watching, and we'll see you again next time.